Okay, let's do an example where a very common example where we want to take a piecewise function and make it continuous. Okay, so what we're going to do is we have this piecewise function here, and we want to pick values for a and b to try and make it continuous everywhere. All right, so let's back up a second. Why might it not be continuous everywhere? Well, certainly f of x being 2 is continuous everywhere in its domain because it's a polynomial, it's a simplest, it's a constant. So whenever x is less than -1, we're perfectly fine. Whenever we're between -1 and 3, we have a line, that'll be continuous everywhere. And whenever we're greater than 3, we're at -2, and that'll be continuous everywhere. But the issue is where these things connect or potentially connect. So I have concerns about x equals -1 and x equals 3. So basically, for a piecewise function, I can analyze each individual piece and then figure out where there might be discontinuities. But then I have to analyze the connection points to see if they actually do connect. So here's how we would do that. So let's look at x equals -1. Let's go through the conditions that we try to ensure. All right, I want to see if it's defined. So does f of -1 exist? Well, there's the x equals -1, and that would say it's 2 there. Okay, so f of -1 is 2. Now let's look at the limit as x approaches -1 from the left, and the limit as x approaches -1 from the right. Okay, of f of x. Okay. But this function looks different when you're on the left and right of -1. If I'm on the left of -1, so let me get rid of some of this. If I'm on the left of -1, then I look like this. So I'm on the left of -1, I'm less than -1. There, I'm in this region here. So the function just looks like 2. And the limit as x approaches -1 from the left of 2 is 2. Okay. As I approach -1 now from the right, I'm bigger than -1. That would put me in here. So my function looks like ax plus b. So now, if I do the limit as x approaches -1 of ax plus b, I would be plugging in x of -1, so -1 for x. So plugging that in there for -1, I would get -a plus b. Okay. So now, what do I have? Well, I have a situation where I have the function defined. Great. I need the limit to be defined. Okay. But that means that these two values would have to be the same. So if this is going to be continuous, then I would need -a plus b to equal 2. Okay? Because that's the only way that these two would be the same, and then hence I would get the limit being defined. Now furthermore, what it would also do is if they both equal 2, then that would equal what the function value is there, and I would get continuity. All right, so I definitely need that. But I need more. I can't figure out a and b from there. Let me go to x equals 3 and do the same thing. F of 3. Well, here's where 3 is defined. So f of 3 is -2. Then I do the same thing. I want to do the limit as x approaches 3 from the left, and the limit as x approaches 3 from the right. of f of x. But when I approach 3 from the left, I'm less than 3, so I get ax plus b. Sorry, that's sloppy. Putting in 3 for x, I get 3a plus b. When I approach from the right of 3, then I'm to the right, I get negative 2. And so that comes out to be negative 2. And once again, if I'm going to have these limit exist here, I need these two to be the same. So I need 3a plus b to be negative 2. That would make the limit exist. It would also make it equal to negative 2, which would match the function value. So what do I need? I need both of these things to be true. So we can, sorry. Negative a plus b is 2. 3a plus b is negative 2. And so basically I just need to solve this little system of equations. I can do that a lot of different ways, but let me just subtract these because I have both b's there. So negative a minus 3a is negative 4a, b minus b is 0, 2 minus negative 2 is 2 plus 2, so 4a is 4, which means a is negative 1. And if a is negative 1 and I put it into there, I get 1 plus b equals 2, or b is 1. So a of negative 1 and b of 1, these values make f of x continuous on the entire real line. Okay, so this is what we had here. Now, it's not too surprising because look at what they are. F is 2 before negative 1, and it's negative 2 after 3. So think about it like this. Here's negative 1, 1, 2, 3. Okay, it's 2 like this. Well, actually up to, and then it's 3 after 3, negative 2. So let me drop down. It's like this, because it's including that too. And basically by asking to make an ax plus b, we're asking to create the line that would connect these, okay? And that's what we end up doing when we make ax plus b end up being negative x plus 1. And that's in fact the line that we get. So that's all we did, is we started with two horizontal lines and we figured out how to connect them to make everything continuous. And now this function here is continuous everywhere on the real line.